In this video, because school was canceled, we're going to review linear regression by going over a separate type of example. Now, in linear regression, what we're hoping to do is to create a line of best fit, which is the straight line that best fits our correlation. So this line of best fit is going to show the least amount of difference between all of our predicted y values, so this is this y little apostrophe value, and all of the actual y values. If this slope, this b value, if that's positive, then we're going to have a positive relationship between our variables. If it's negative, then we have a negative slope. That means we have a negative relationship. So what I've done is I've gone ahead and I have written out 10 values, so n is equal to 10, of hours of sleep and test performance. Now here are our equations that we're going to use to find b, which is the slope, and then the y-intercept, which is a. So b is equal to n times the sum of the cross products minus the sum of x times the sum of y divided by n times the sum of x squared minus the sums of x's squared. Then once we get this b value, we'll be able to plug this in to our y-intercept equation and do the mean of y minus the slope times the mean of x. So one of the first things that we should do is go towards this end, just draw a bolder line, and then what we're going to do is we're going to find the mean values for our x and our y. Okay, so what I'm going to do is I'm going to go ahead and grab my calculator, and we're going to go and put in all these values. So 4 plus 5 plus 9 plus 3 plus 2 plus 5 plus 7 plus 10 plus 8 plus 8 divided by 10. So the mean of x is 6.1. Now for y's, we have 50 plus 60 plus 100 plus 50 plus 40 plus 90 plus 90 plus 95 plus 75 plus 85 divided by 10, 73.5. Okay, so note that we solve for the mean values because we need them up here. So we already have our n as being 10, right? So now what we should do is we can do and solve for the cross products. So xy is going to be x times y, so 4 times 50 is 200. 5 times 60 is 300, 9 times 100 is 900, 150, 80, 450, 630, 950, 8 times 75 is 600, and then 8 times 85 is 680. So our sum of the cross products is going to be 200 plus 300 plus 900 plus 150 plus 80 plus 450 plus 630 plus 950 plus 600 plus 680, which is 4,940. Now let's, at the same time, add our sums of x's. So we have 4 plus 5 plus 9 plus 3 plus 2 plus 5 plus 7 plus 10 plus 8 plus 8. So that's 61 for x. And then the sum of y's are equal to 50 plus 60 plus 115 plus 40 plus 180 plus 95 plus 75 plus 85 is 735. Okay. Now the last little part is the sum of the x squareds. So what we're going to do is we're going to do 4 squared plus 5 squared plus 9 squared plus 3 squared plus 2 squared, etc. So let's go and do that. So we have 4 squared plus 5 squared plus 9 squared plus 3 squared plus 2 squared plus 5 squared plus 7 squared plus 10 squared plus 8 squared plus 8 squared. That gives us 437. Okay. So what we do now is we just fill in our equation. So here we have b is equal to n, which is 10, times the sum of x, y, so 4,940, minus the sums of x's, which is 61, times the sum of y, which is 735. We divide that by 10 times the sum of x squareds, which is 437, minus the sums of x's, which is 61, and we square that. So our numerator ends up being 10 times 4940, so 49,400, minus 61 times 735, which is 44,835, divided by 10 times 437, minus 61 squared, which is 3,721. So that ends up being 7.03. Now our intercept is going to be the mean of y, which is 73.5, minus b, which is 7.03, times the mean of x, which is 6.1. So this is going to be equal to 73.5 minus 7.03 times 6.1, 30.62. The real answer is 30.617, but we'll round it to 2. So our line of best fit is going to be y equals 7.03 x plus 30.62. Okay. Now from this equation, what we can do is we can put in a value of x and we can get an estimated answer. So a predicted y value. So for instance, if we have hours of sleep up here, what might the score be if somebody gets 6 hours of sleep? We don't really have a 6 in here, so all you would do is do y hat equals 7.03 times 6 plus 30.62. So you do 7.03 times 6 plus 30.62, and the answer ends up being 72.8. So using our linear regression model, so using our line of best fit, what we're able to do is we're able to estimate and predict that somebody that gets 6 hours of sleep will score around a 73%. Now these are just predicted values though. Now, what we can do apart from this is find what's known as the coefficient of determination. Now the coefficient of determination is r squared, and so this r is that same Pearson correlation coefficient that we've seen before. Now what this tells us is it talks to us about how much of the variability in y can we explain through x. So if we go about and find r squared for this example, we'll be able to say how much percentage of the test scores, how much of the variability in test scores can we explain just by hours of sleep. So now what we're going to do is we're actually going to calculate our r value. So we're going to actually go back and do a correlation. Now this is important because on your test, you're going to have to create a correlation in order to find out that r squared. Note here, we haven't calculated r. We calculated a slope, but that's not the same as r. So remember that your formula for r is the sum of squareds for x and y divided by the square root of the sums of x, or sums of squared for x times the sums of squared for y. So you're going to have to use these values to find these. Now we already have the mean of x and the mean of y, so that's what we need. Now in order to do the sums of squares for x, we are going to have to sum, right, these deviation scores. So 4 minus 6.1 squared plus 5 minus 6.1 squared plus 9 minus 6.1 squared plus 3 minus 6.1 squared plus 2 minus 6.1 squared plus 5 minus 6.1 squared plus 7 minus 6.1 squared plus 10 minus 6.1 squared plus 8 minus 6.1 squared plus 8 minus 6.1 squared. For the sums of squares of y, we're going to do the same thing, except we're going to use the mean of y. So we will have 50 minus 73.5 squared plus 60 minus 73.5 squared plus 100, and so on. So what I'll do is I'll write these out. Now your sums of squares for the cross products are going to be that for each of these pairs, so 4 minus 6.1 times 50 minus 73.5. So these are these first values. Then you're going to add 5 minus 6.1 times 60 minus 73.5. That's going to be your sums of squares for x, y. So when you do all these values, you're going to be able to come up with your r value. So what I'm going to do is I am going to put these into the calculator, and I'm going to come up with these values. So I definitely recommend that you follow along. So for the sums of squares for x, I got 64.9. Now for y, I got 4,252.5. Now for the sums of squares for x, y, we have 4 minus 6.1 times 50 minus 73.5. So we have 49.35. And I'm going to add each of these. So 5 minus 6.1 times 60 minus 73.5, 14.85, 9 minus 6.1 times 100 minus 73.5, 76.85, plus 3 minus 6.1 times 50 minus 73.5, 72.85. 2 minus 6.1 times 40 minus 73.5. 137.35. 5 minus 6.1 times 90 minus 73.5. Now keep in mind when you have a negative value, make sure that you keep that negative in there. Okay, so we have 1, 2, 3, 4, 5, 6. So 7 minus 6.1 times 90 minus 73.5. So plus 14.85. So plus 10 minus 6.1 times 95 minus 73.5. Eight minus 6.1 times 75 minus 73.5. 2.85, and then plus 8 minus 6.1 times 85 minus 73.5 is 21.85. So if we add these values all together, so 49.35 plus 14.85 plus 76.85 plus 72.85 plus 137.35 plus negative 18.15 plus 14.85 plus 83.85 plus 2.85 plus 21.85, you get 456.5. So now that we have all these values, what we're going to do is we're going to put them into our R equation. So sums of squares of x, y is 456.5 divided by the square root of sums of squares of x, 64.9 times 4,252.5. So then our value for this set of data is going to be equal to 456.5 divided by the square root of 64.9 times 4252.5. Our R value is equal to 0.86895. So what you can do is just round that to 0.87. Now this is R, this is the correlation coefficient. What we're trying to do is figure out R squared. So all you do is just take 0.87, square it. So 0.87 squared is 0.7569. So roughly 75.7% of the variability in our test scores can be attributed to lack of sleep or hours of sleep. Now note that, again, roughly about 24.3% is unaccounted for. So we could probably include another type of variable to see if that helps to explain the relationship a bit more. And this is where something like multiple regression can come into play, because if you measure something like hours of sleep, but then you also measure something like stress, you can actually throw the variable of stress into this type of equation as well, and you're going to be able to talk about the relationship among your predictor variables and see how that leads to differences in your actual correlation or your coefficient of determination. So one thing that I want to do is I'm going to open up a program on my computer called Jamovi. Now Jamovi is a free software that works in the same sort of capacity as R, which is a programming software, but then it also mirrors that of SPSS, which is a statistical program. And so what I'm going to do is I'm going to actually put in this data, and then we're going to actually see how that looks on the output on this computer, okay? So we have our hours of sleep. So we'll call this variable sleep, and it's a continuous variable. So our values were 4, 5, 9, 3, 2, 5, 7, 10, 8, and 8. Our second variable was test performance. So I'll just put test, it's a continuous variable. And then we have 50, 60, 100, 50, 40, 90, 90, 95, 75, and 85. Okay, so what we're gonna do up here is click regression. We're gonna do linear regression. So our test is our dependent variable. We're going to look for the relationship between sleep. And what we see here is our R value is 0.869, which is exactly what we found down here. Now our coefficient of determination, our R squared value, .755. We got 0.756. Again, that can be due to rounding error. Now, what I want to point out to you is our linear regression equation. 7.03 is our slope. There you go. And then our y-intercept was 30.62. Here we got 30.59. So that's pretty okay. Again, a lot of stuff due to rounding errors possibly, or just precision in computing. So we got our equation pretty good. We got it accurate. That's excellent, right? So that is linear regression in a nutshell. And here is all of the work done out. You will be responsible for this type of problem on your final exam.